Imagine a company that has revolutionized the car industry, making electric vehicles mainstream and inspiring a global shift toward clean energy. That company is Tesla, but even a giant company like Tesla is not immune to global challenges. Our presentation today is titled Global Business Crisis of Tesla. My teammates and I will explore and explain how global chain disruptions and international dependencies have created serious obstacles for Tesla's growth and performance. Tesla, founded in 2003, is one of the world's leading electric vehicle manufacturers. It's known not only for its cars but also for its battery technology and clean energy products. Because Tesla operates globally, it depends on a complex international supply chain, sourcing materials like lithium, nickel, and microchips from suppliers around the world. This global reach makes Tesla vulnerable. Any delay or disruption in one part of the chain can slow down production and delay vehicle deliveries. In recent years, events like the COVID-19 pandemic, political tensions, and shortages of raw materials have exposed how fragile global trade really is. For Tesla, these disruptions directly impact performance, cost, and customer satisfaction. This report explores how supply chain disruptions have become a global crisis, why they matter for international business, and how companies like Tesla can prepare for future risks. Now, let's look at the broader global crisis affecting Tesla and other international brands. Most global companies rely on suppliers spread across different countries. A single setback, whether it's a health crisis, political conflict, or shipping delay, can shut down production halfway across the world. For Tesla, building electric vehicles requires very specific materials and technology. When this became scarce, manufacturing costs rose and factory schedules were delayed. Shipping bottlenecks and trade disputes added even more uncertainty, making it difficult for Tesla to secure the resources needed to meet customer demand. These disruptions aren't just temporary problems. They have evolved into a global business crisis that affects profits, efficiency, and customer trust. To stay competitive, Tesla must strengthen its supply chain and make it more flexible. Another major challenge for Tesla is its heavy dependence on Chinese suppliers. The Gigafactory in Shanghai is one of Tesla's main export hubs, and many of its parts, including batteries, come from local Chinese contractors. This setup helped Tesla scale production quickly and keep costs low, but it also created risks. Political tension between the United States and China, new trade tariffs, or even local lockdowns can instantly disrupt Tesla's global operations. To reduce these risks, Tesla is working to diversify, building new factories in Europe and North America and partnering with local battery producers. However, breaking away from China suppliers is slow and expensive because China dominates the EV materials market. Tesla's challenge now is finding the right balance between cost efficiency and supply chain security. Now I'm going to pass the next presenter to explain the next part.
Now I will present about the application of concepts. The crisis of Tesla falls under two concepts, where the first one is global operations. In global operations management, everything relies on having a smooth, perfectly coordinated flow of parts across borders to keep factory assembly lines moving. Let's look at the first major issue, shortage of raw materials. Electric vehicles are highly complex machines that require advanced core technologies like microchips, semiconductors, and lithium battery cells. When there is a global shortage of these key parts, it creates immediate bottlenecks. For Tesla, these aren't just minor delays because these components control essential car functions. A shortage directly disrupts factory operations. This limits the numbers of vehicles Tesla can physically manufacture, which ultimately leaves customers stuck on long waiting lists. This brings us to the second major issue on this slide, supplier dependency. Tesla relies heavily on suppliers in China, particularly because China refines the vast majority of the world's battery minerals. This creates massive logistical bottlenecks. Think about the geographical distance. These vital materials have to travel all the way across Pacific Ocean to reach assembly lines in the US. If a Chinese supplier experiences even a small delay, that long shipping transit time makes it impossible for Tesla to get replacement parts quickly. This rapidly drains their local factory inventory and forces incredible expensive production halts at their US facilities. Now, Let's transition to our second core concept, political forces. Government actions and policies have a direct influence on how global businesses operate. First, let's discuss trade policies and tariffs. Governments often use import duties as political tools to protect domestic markets or pressure foreign rivals. When states impose high tariffs, it immediately disrupts international supply chains by driving up component costs. A real-life example of this is the intense US-China trade war. The heavy tariffs imposed on Chinese imports dramatically inflated Tesla's production expenses and squeezed their profit margins on essential parts like battery materials and electronics. To adapt to the strict trade barriers and keep factories running, Tesla is forced to constantly alter its shipping routes, pause production lines, and search for expensive non-tariffed alternative suppliers. Next, let's look at political stability. Political stability means a country has a steady government, which is important because it gives businesses the safety and predictability they need to keep factories running. Tesla's highly globalized supply chain is deeply exposed to regional instability, especially with ongoing tensions in Greater China region, Taiwan, and the South China Sea, which is a major hub for semiconductors and electronics manufacturing. Because of this, Tesla has explicitly instructed their vendors to move their production lines completely out of China and Taiwan to politically safer Southeast Asian nations like Thailand to ensure that a sudden outbreak of geopolitical conflicts doesn't instantly shut down Tesla's global vehicle output. Ultimately, this forces multinational corporations like Tesla to sacrifice low manufacturing costs in exchange for long-term supply chain and security survival.
To navigate supply chain disruptions, Tesla implemented a series of strategic decisions that set them apart from traditional automakers. First, Tesla adopted vertical integration as a core strategy, internalizing over 95% of its manufacturing processes, including battery cell production, power electronics, and proprietary software, under one roof in their gigafactories. This minimized their reliance on external Tier 1 and Tier 2 suppliers, which protecting the company from the industry-wide failures that affected others. Second, Tesla utilized a software-defined manufacturing to maintain production resilience. Because they designed their own firmware, Tesla engineers were able to rewrite vehicle code in real time to support readily available microchips when standard components were in short supply, which allowed assembly lines to continue moving. Third, the company employed a strategy of regionalized manufacturing or strategic localization by establishing gigafactories in major markets such as Shanghai, Berlin, and Austin. This approach reduced geographic risk, lowered logistic costs, and shielded Tesla from the shipping volatility and cross-border trade tariffs that often disrupt global supply chains. Finally, Tesla maintained a direct-to-consumer model that bypassed dealership networks. This model ensures a direct relationship with customer and provides the company with a real-time data visibility. By utilizing this data, Tesla is able to adjust production plans accurately, preventing the inaccurate demand forecasting that leads to a massive inventory inefficiency.
In this part, I'm going to elaborate on the risks and impacts of the strategic decisions that has been discussed earlier. Firstly, Tesla vertical integration strategy might lead to the risk of higher operating costs. This is because substantial capital investments is required to build and operate gigafactories while managing most operations activity internally. This also increases operational complexity because the company is responsible for manufacturing, quality control, and supply management instead of relying on suppliers. If international operations fail, Tesla bears full responsibility for production disruptions. As for the impacts, vertical integration increases Tesla's financial burden as the company must invest in manufacturing, facilities, technology, workforce, and internal operations. This may reduce short-term profitability and increase the complexity of managing the supply chain. Secondly, software-defined manufacturing may face the risks of technology failure, cybersecurity threats, and dependence on skilled engineers. This is because software-defined manufacturing may be vulnerable to system failure or cyber attacks which could potentially disrupt manufacturing operations. Besides, developing proprietary software and firmware requires continuous investment in research and development, cybersecurity protection, and highly skilled engineers. These requirements demand significant financial resources, technological upgrades, and continuous workforce to ensure efficient and secure manufacturing operations. System failure or cyber attacks can disrupt Tesla manufacturing's operations, resulting in production's downtime, delayed vehicle deliveries, and increased operational costs. This disruption may also affect supply chain's performance by slowing productions and reducing the company's ability to respond efficiently to customer demand. Consequently, maintaining robust cybersecurity measures and reliable software systems is essential to ensure continuous and efficient manufacturing operation.
Third, strategic localization may encounter the risk of local supplier availability issues and compliance with regional regulation. Finding and developing reliable local suppliers that can meet Tesla's strict requirements for electric vehicle components such as batteries, semiconductors, and advanced automotive parts will be a challenge. In some regions, local suppliers may not have the required technology production capacity or quality standard, which may make it difficult for Tesla to establish a fully localized supply chain. In the meantime, Tesla faces challenges in adapting its operations to different market requirements such as EV regulations, environmental standards, labor law, and government policies. Differences in regulations across countries may require Tesla to modify its manufacturing processes, invest in additional certifications, and allocate resources to ensure compliance. The impact of local suppliers' availability issues on Tesla is that it may cause difficulty in maintaining a stable supply chain, leading to potential delays in production, higher procurement costs, and continued dependence on international suppliers. If local suppliers cannot meet Tesla quality and technology standards, Tesla may need to invest in supplier development or imports components, reducing the benefits of localization. Meanwhile, compliance with regional regulations can increase Tesla operational complexity and cost as the company must adapt its manufacturing processes, obtain certificates, and comply with different environmental, safety, and labor requirements in each market. These challenges may slow down expansions, increase operating expenses, and affect Tesla's ability to efficiently implement its localization strategy. Lastly, Tesla may experience increases on operational responsibility. By adopting direct-to-consumer model in its operation, Tesla eliminates the needs for traditional dealerships and intermediaries. This will cause Tesla to be fully responsible for sales, vehicle delivery, and after-sales services, which will require a greater investment in customer service infrastructure and logistic capabilities. By establishing local manufacturing facilities and supply networks in different regions, Tesla becomes responsible for managing more aspects of the business, including local supplier relationship, production processes, workforce management, quality control, and compliance with regional requirements. The increased scope of operation can make business management more complex, especially when Tesla operates across multiple markets with different conditions and expectations. The increase in operational responsibilities may lead to higher operating costs and greater complexity in managing Tesla global operation. Tesla may need to allocate more resources to coordinate local facilities, train employees, monitor suppliers, and ensure consistent product quality. This could slow down decision-making processes,
increase management challenges, and reduce operational efficiency if these responsibilities are not effectively controlled.
In conclusion, Tesla's deep exposure to macro-environmental risk and over-reliance on centralized Chinese suppliers highlights the critical need for a strategic shift towards long-term supply chain resilience. To reduce future risk, Tesla should have aggressively diversified its global sourcing network much earlier to reduce dependence on a single region, while concurrently accelerating its vertical integration strategies to bring battery minerals refining and chip customization entirely in-house. Moving forward, the company must continue to prioritize technological agility and supply chain security over cheap global outsourcing, even if it incurs high setup costs. By expanding its localization of gigafactories near core consumer markets, ensuring production remains uninterrupted during international geopolitical crises.